Harvard astrophysicist Avi Loeb has suggested that the 3 Atlas is actually some type of alien technology. The numbers just changed, and with them, the complete narrative of the 3 Atlases. For months, astronomers assumed this interstellar visitor only skimmed past the red planet. But astronomers are continuing to follow a newly discovered object, most likely a comet, from outside our solar system. The interloper, named 3 Atlas, was first spotted on July 1st, a spectacular but harmless flyby. However, new calculations from Harvard's team, along with independent analysts inside NASA's Jet Propulsion Laboratory, have revealed something extraordinary. This is not a rock, and in that case, maybe it's targeting the inner solar system. We know that the trajectory is very well aligned with the planets. 3 Atlas's trajectory is not simply precise, it's actively tightening, and its speed is changing. And now, for the first time, the latest data show it could actually collide with Mars. If you're fascinated by discoveries like this, make sure to subscribe so you never miss the latest updates on space mysteries. 3 Atlas is moving more quickly than anything humanity has ever tracked inbound from interstellar space, nearly 87 kilometers per second relative to the Sun as of this week. In practical terms, it's covering the distance between Earth and the Moon in less than 80 minutes. Every hour it travels, gravitational tugs from the Sun, Jupiter, and Mars adjust its path by micrometers per second, tiny changes that become enormous across tens of millions of kilometers. The Mars Reconnaissance Orbiter proved that the object's comet's hazy halo has doubled in brightness since August, with strange high-energy spikes in ultraviolet. That's not typical cometary physics. The CO outgassing rate is far beyond what's seen in any solar system comet. Instead of stabilizing as it nears the Sun, 3 Atlas is acting like a guided missile, self-adjusting, accelerating, and course-correcting by releasing plumes of gas in deliberate pulses. The new trajectory analysis puts its closest approach to Mars at just 1.95 million kilometers on September 26, 2025. For a planetary astronomer, that's a hair's breadth. At this distance, Mars' gravity can exert measurable influence on the comet, a piece of what would have become a planet in another star system. And here's a terrifying twist. A mere 10 kilometers per second of increased speed could tip the orbit enough to result in a direct hit weeks later. Think about that. 3 Atlas only needs a fraction of the momentum SpaceX's Starship uses to launch from Earth to change its destiny from flyby to collision. Furthermore, these momentum shifts are happening right now, hidden in its tail. Spectroscopy from Gemini South in Chile has revealed something no one can yet explain. Instead of steady, random venting of sublimated ice, 3 Atlas's tail emits gas in clock-like pulses once every 17 minutes, perfectly synchronized over days. These pulses produce microaccelerants in the exact direction needed to align with Mars' orbital plane. No natural process in the study of comets produces a rhythm that precise. In comets, jets erupt when sunlight hits fresh ice patches, but chaos reigns during those eruptions. They don't repeat like a metronome. Here, the pulses look engineered like attitude thrusters on a spacecraft. If the pattern holds, by September 19th the comet will have imparted enough lateral thrust to close the remaining missed distance to less than 50,000 kilometers, closer than some of Mars' moons. An object moving quickly, the size of Manhattan, is heading straight for our solar system, and it will make its closest pass to Earth on December 17th. Comet, asteroid, or some other thing. That Harvard astrophysicist believes there's a strong likelihood this is a craft of alien origin, and the implications for humanity would be profound. It may not be a rock. It is called 3 Atlas. So, what's the best case for why this object may be extraterrestrial in nature? First, its brightness implies that if it represents reflection of sunlight from a solid object, it needs to be 20 kilometers in diameter. That's bigger than Manhattan Island. Furthermore, this is a huge rock. The previous interstellar objects were hundreds of times smaller. So, it is absurd that the third object from interstellar space would be 100 times bigger than the previous two, and we wouldn't see anything in between. If you look at where this has gone, the object is indeed perfectly aligned with the plane of the planets around the Sun. The fundamental question is, was this designed by intelligence? One major outburst could then push it into a collision trajectory. At its current mass estimated at 10 billion tons of ice and dust, heavily irradiated with a metallic core perhaps for 100 meters across, if Mars were hit directly, energy would be released equivalent to 2 million megatons of TNT. That's thousands of times the largest nuclear device ever tested on Earth. The resulting crater could be 60 kilometers wide and 5 kilometers deep, throwing debris into Mars' orbit and potentially injecting some into interplanetary space. Because Mars is home to numerous planned and active spacecraft, from the Mars Reconnaissance Orbiter to the Perseverance rover, an impact would not only wreak havoc on the planet but also shatter decades of scientific investment. Communications relays, climate monitoring, and life search missions could all be hampered overnight. Inside NASA, quiet preparations are underway. Leaked memos show mission planners already using the Mars Reconnaissance Orbiter as a forward radar to image and track 3 Atlas's inbound vector. High-gain antennas at Goldstone have been repurposed to bounce radar at the core of the comet. The results are still classified, but one insider described them as unlike any echo we've ever recorded, hard metallic returns instead of the signatures left by soft ice. If these leaks are accurate, 3 Atlas may not be just ice and dust at all. Its core might contain alloys impossible to form naturally in deep space, hinting at an artificial interior surrounded by sacrificial ice. Professor Avi Loeb and his student Adam Hybard have long argued for a technological explanation. Their new paper, currently undergoing peer review but already circulating online, lays out a scenario in which 3 Atlas is a directed messenger launched by an advanced civilization. Instead of simply passing through our system, it would graze Mars to deposit probes or crash deliberately to release detectable materials from underground storage areas. They calculate that, with each pulse of gas, the object is not losing mass randomly but steering itself, sailing on its own sublimated exhaust. This would allow it to adjust its trajectory as it enters our planetary neighborhood, the way a spacecraft uses thrusters for reaction control. As if to confirm the worst suspicions, the European Mars Express of ESA has taken pictures, 3 small, glinting objects in high orbit, forming a triangle over Mars. Initially dismissed as cosmic rays, they appear in the same positions on 3 consecutive orbits. Could these be ejected by 3 Atlas as scout probes in a previous pass? NASA is urged by Loeb to cross-reference these glints with archival MRO data to see if any matching metallic fragments are already on the surface. If found, it would be the first evidence of interstellar technology ever recorded, far more significant than the meteorites from Mars that we've studied on Earth. The timeline now looks chilling. September 26, 2025 marks 3 Atlas crossing Mars's orbital path. September 19th to 30th is the critical window for final course corrections via gas pulses. During this period, the comet's speed relative to Mars will be about 57 kilometers per second. At that velocity, even a glancing strike could vaporize cubic kilometers of rock and discharge dust into space. Critics argue no natural comet can change course by 10 degrees using sublimation alone. That would take more than 10 billion joules of focused energy, far more than any comet outburst we've ever seen. Yet, that's exactly what is implied by the trajectory.